How can they construct a binary tree from its preorder and inorder? We have this tree definition here. Actually, it's defined in this pretty tree module, which allows me to draw the trees in console. And we have these two functions which builds inorder and preorder for a tree. Okay, let's look at some trees. I will load my module here and I will print some tree example. Okay, we have this tree. Now let's build its inorder and its preorder. Okay, this is what we have here. Now let's start from the idea how can we construct a binary tree from this information. Okay, we have a preorder. This means that we know the main root of our tree. This is A, because preorder at first always prints the root of the tree. So if we take this A and find it in our inorder, we can find the nodes in the left subtree of the tree with root A and all the nodes with in the right subtree with root A. So the left subtree defined in this sublist and the right subtree defined in this sublist. Okay, because this comes from the inorder definition. Using this and recursion, we can solve this problem. Okay, let's start. I will call my function rebuild, and we will start from type signature. It takes some list of type A with preorder and some list with inorder, and it produce a binary tree of type A. Also, we need to add equivalence type class here for A. And let's start from the simplest case if we have two empty lists. This means we have empty tree. Otherwise, if we have some list with preorder and inorder, we need to build a tree. So we build tree with this node constructor. We start with constructor. Then we need to define the root of the tree. I will define it later. And also we need to go to recursion here and define our left subtree from our L preorder and our L inorder. And we need to define the right subtree with our R preorder and our R inorder. I didn't define this yet, these sub preorders yet, and let's do this. So at first I need to define a root, and root is, as I said, this is the head of our preorder. In this case, this is A. Okay, so I need to define it as head of preorder. Okay, now we know a root. How can we define the inorder of this left subtree and its preorder? So let's start with left in order. Of course, they can take this information from this total in order, and we know the root A. We need to just extract this sublist from the left. And we can do this with take while function. Okay, it defined it in this module. And let's look at its type signature. Take while. Okay, it takes some predicate from A to bool and a list of A's and produce a list of A's. So the predicate this will be this is when we come from the left here. We need to take the elements until we find the root. This means that our predicate is not equal to root. Okay, and we need to provide a list from which we extract this sublist. Okay, now let's define the right in order. This is can be defined exactly the same, but we need to use drop while function. So we skip all the elements from the left until we find the root A. Okay. The predicate will be exactly the same. And if we use the drop while, we will drop all the elements from here, and we will receive this sublist. And this means that they need to take tail of it. So now we have the in orders of our left subtree and in orders of our right subtree. And they need also their preorders. So how can we define the preorder? We start from the left subtree preorder, and to define it, if they have this subtree in order, how can we define its preorder? We can extract it from here. We need to pick up from these sublists all the elements which present in the in order. So this means that we need to just take the intersection of two lists. Intersection, and the left list is in order, and then we extract the information from the all preorder, from the total preorder of the total tree. And so on, we can define the preorder for right subtree. We also do the intersection, but with right tree in order. Okay, and I think this should work. Let's try to recompile this. Oops, intersect. I need to change the brackets here. Okay, let's recompile, and it's done. Now let's try to rebuild our tree from this information. So we have preorder, and we have inorder. And we can see that they have some tree. Now let's print it in a nice way. And it's exactly the same as our started tree. Yes? I think yes. Okay, we can print it just here. Yes, these trees are the same. And this is an interesting idea how can we find what two trees are the same. This maybe the next video, the topic of the next video. So guys, thanks for watching. Push like button, push subscribe button, write comments, and see you later.